All right, we're still in section 4.4 here because there's one more representation we need to go over for a way to show your data. This is in case you don't want to write a list of data, how long or how big of a piece of paper you'd have to have. A stem and leaf plot can summarize it by reducing the amount of times you have to write the tens place. So for example, the numbers on the left side of this line stand for the tens place. I put a little note up here on the side if you'd like to add that to yours. And then on the right-hand side, the numbers on the right stand for the ones place. So this down here at the bottom, this 8/2 equals 82, is a legend telling us that the 8 stands for the tens place and the 2 stands for the ones place. So an 8/2 would be an 82. So let's go see what you think of this data, see if you understand what I mean. And so just if I wanted to write out the data in list form, this first one, the 1 and the 7, 1/7, that stands for 17. Then the 4/1, 41, 41 again, 42, 49, 53, 53, 53, 53. How many of those are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 61, 63, 64, 66, 67, 68, 69, 71, 73, 75, 75, 77, 82, 82, 83, and 84. So there's my nice long list of data from the stem and leaf plot. If after working with the data in a stem and leaf plot, you're like, no, I do better when it's in list form from least to greatest, feel free to take the data from any stem and leaf and list it out and work with it like normal. But I'm going to work with it here in this data set. So let's go down and look. Question 1 says how many students were polled. So the tens place is just a placeholder. How many is really just counting on the right. So I'm going to put a little note here to say count the numbers on the right only for this one. Okay, so here I go counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 3 to 4 to 5, 26. I've got 26 students were polled. Find the mean. Yes, that actually means we're going to be adding up all those pieces of data. So I'm pulling it straight from the green stem and leaf plot from the top. I'm going to go 17. Grab your calculators and do this with me so you can check me and make sure I get it right. Okay, I got 1545, but I'm going to do it one more time to make sure. So grab your calculator if you didn't the first time and add it up for me to double check me. And of course, I got a different number. So here I go adding one more time. Okay, so the second time I added it and the third time I added it, I got 1615. Does that sound better? I hope somebody added it for me just to double check for me. Okay, 1615 divided by 26 is going to give me my mean. And it comes out to 62.12 if I'm rounding. That means that's my average. Find the mode. When you were adding that, did you notice how many 53s we had? There were 5 53s, so that's my mode. Now we're doing Q1, 2, and 3. Since there's 26 pieces of data, it's an even data set. That means we're going to have to find the middle of the middle. And that's going to happen halfway through it. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I cut right there, and then I count the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then right there in the middle of 64 and 66 is my median, my Q2. So 64 and 66, the middle of that is 65. Okay, so my Q1, now I've got 13 pieces of data on the first half and 13 pieces of data on the second half, so there's going to be a true middle. 1, 2, 3, 4, 5, 6, 7. So there's my Q1. And 1, 2, 3, 4, 5, 6, 7. There's my Q3. So 53 is my Q1. My Q2 was 65. And my Q3 was 75. IQR is the Q3 minus the Q1. And so is that 22? I'm grabbing my calculator. And upper and lower outlier cutoffs. Q1 minus 1.5 times the IQR. So that's going to be 53 minus 1.5 times 22. And then Q3 plus 1.5 times the IQR is going to be 75 plus 1.5 of 22. Let's go calculate that. 22 times 1.5. So I've got a 33 at the back. So 53 minus 33 is 20. That's my lower outlier cutoff. 75 plus 33 is 108. That's my upper outlier cutoff. So looking at my data, do you see how my highest piece of data is an 84, my max? So there are no upper outliers. My lower piece of data, lowest, is 17. So that is an outlier. How many outliers are there? 1. It's the number 17. What percent of students spent $53 or more on gas? So now we're looking at all of these pieces of data. So 1, 2, 3, 4, 5. Remember, I'm just counting the back numbers. 1, 2, 3, 4, 5. 21 out of 26 spent 53 or more on gas. And that's 81% of students. I got 0.807 when I put that in the calculator. Okay, how'd you do? Now, I didn't ask you to write a box and whisker plot here, but let's put it down here at the bottom just for purposes of remembering how to do it from the last section. So if I draw the line, Q1 to Q3, and my whisker is going to go out to the max, and my whisker on the left is going to go down to the min, not counting the outlier. So this goes down to a 41, And then my outlier goes way out here, 17. So this goes from 53 to 75 and then 65. So Q1, Q2, Q3. How'd you do? Do you remember how to draw those?